The College Board actually says that this is a hard question, but I think this is very, very easy. Many of you will get this just by memorizing things about quadratic equations, but I guess there still are instructions to follow because we have a story and we need to be able to interpret the pieces of that story. So we can see from the choices that we're dealing with a quadratic equation, a parabola. But let's look at what they give us in the story. Machine launches a softball from ground level. The softball reaches a maximum height of 51.84 meters above the ground at 1.8 seconds. So just like that, maximum, remember, when we have a quadratic, is code for vertex. And it hits the ground at 3.6 seconds. So that's hits the ground is when h is 0. And since h is y, this is code for x-intercept. So they're giving us 2 points, and we need to represent them. Now, if you are looking at these choices, you just might be like, well, I mean, it's got to be D, right? Because that's the vertex, and the vertex here is 1.8, 5.84. The vertex formula in general is A times x minus h squared plus k, where hk is the vertex. So in this case, our hk would be 1.8, which is my oh, see, be careful of the H. I'm messing you up there maybe. This is Y, so you just got to be careful they're doing that. So maybe that's what makes it hard is they're messing up the letters. But H is the X coordinate of the vertex, which in this case is the T, and that's 1.8 seconds. And then the height, which is the Y in this case, but is K in the generic formula, is 51.84. So now I see why they might be making it harder. So they're trying to flip you with the H and the K. But don't be intimidated. The formula is the formula. So there you go. That just kind of fits in. The only thing I might be nervous of is the negative 16, right? I mean, the equation matches with the vertex, but maybe they did something and they manipulated it in some way. So at that point, the instruction changes. It just becomes plug points into equations. So I'm not going to plug in that vertex point because I kind of know that's going to work in D. What I would do to be sure is plug in this x-intercept point, which is that the height is 0 when the T is 3.6. So let's just try it, right? So we want to do negative 16 times 3.6 minus 1.8 squared plus 51.84. I mean, I can do it in Desmos just to show you. Negative 16 times 3.6 minus 1.8. Oh, Desmos is so tedious sometimes. I would definitely do this on my handheld calculator if I wasn't showing it to you, but here we are, 51.840. Perfect. Check. Done. I wouldn't bother to check the others. You could, and if you didn't know the vertex thing, right, then that's also no excuse, right? Because the vertex is just a point, and it will work in the equation if whatever format it's in. So you don't even need to think of it as a vertex. You just need to realize they give you 2 points, plug points into equations, test them out. Only one of these will work. So remember, that's like the ultimate instruction we're always trying to follow is plug points into equations. They don't need to say it. You need to say it in your own head, but that's kind of where we're trying to get to it in many ways. Here, though, the points are distorted, right? They're twisted up into the story, but we still need to be able to kind of follow that, read these as instructions and kind of understand what points they're giving us based on the story. And projectiles, those are it's a very common situation for quadratics because it's like the only situation where we have quadratics in real life. So you're going to see things like a maximum and hitting the ground, those kinds of things in other questions on the SAT.